Hello, this is the run through on how to calculate the correlation coefficient kind of by hand. Really, you're using spreadsheets, but it's not super important to be able to do this, but it does help you give a little more depth to your understanding about what R is and how it's calculated. So, we're going to be using this formula that we talked about last class. We're going to be calculating z scores of x and z scores of y, summing those up, and then dividing by n minus 1 for the class. So we need to collect data for the class first. So there should be some tape measures in the closet. If you get out the tape measures and measure everybody's height versus their arm span. Height versus arm span. And on the board, we need to write this data down. So we're going to make a table on the board, and let's call the height the explanatory variable and the arm span the response variable. In reality, it really doesn't matter which one's which. You just have to make a decision, or you have to know what are you trying to predict. So if you're trying to predict arm span, then that has to become the response variable. If you were trying to predict height, then that would become the response variable. So sometimes it doesn't make sense one way or the other, and it really doesn't have to. It's all about what are you trying to predict, and then what indicator are you using to do that? Because for some reason you have that information, or you can collect that information. Okay, so measure everybody's height and arm span, and you're just going to list them out. Make a list here, and then when you get the whole class's data on the board, then I want everybody to go to a TI Inspire and open it up and write in your class's height and arm span. And you can see I have the list here from the class from a previous class. Okay, so we got all the data on the lists, and you can pause this any moment, right? You probably need to pause this along the way until everybody's caught up and then start it again. Okay, so once you get all the data on the board, the next step is to calculate the one variable stats for each of those lists. So right here, I did the one variable stat for height and then the one variable stat for arm span. And of course, you're going to get different numbers because you're in a different class. But I'm interested in the mean of those lists, and I'm also interested in the standard deviation of those lists, S of x. Why? Well, because we are going to calculate z-scores, and we should all know by now that a z-score is your values, right? Whatever your values are, minus the mean, and then that whole thing is divided by standard deviation, right? This should be old news by now, and you should know how to calculate a z-score. Okay, so that's what we're doing. So these values are going to be an actual list of all the values, and we're going to use the name to do that, like height or arm span here, and then subtract the mean as whatever that number is for you guys, and then divide by standard deviation. So here's what it looks like. Okay, so we got our one variable stats. I got my mean and my standard deviation for each list. Okay, move on over to a couple columns over here. You'll see that I called this one ZX and this one ZY. And if I go to the formula bar, you can see down here, down at the bottom here, right down here, you can see the z-score formula, right? I just type in the word height because that's what I named my column list. And then minus, I use the cell number, but you can type in the number of the mean. It's going to be more accurate if you actually just use a cell. So I use D2. Yours might be a different cell, wherever your mean is for the height. And then I divide it by D5, which is where my standard deviation is for the height. Okay, don't want that. Do the same thing for ZY, but in this case, I'm using arm span instead of height. And instead of D, I have E, right? E2 and E5 for mean and standard deviation. Okay, so again, pause the video and get your z-scores for both of your original lists. Okay, so, right, your height and your arm span list, and now they have been turned into z-scores. So we have two lists of z-scores. All right. Once you get your z-scores, now if we go back, let's go back to the formula. So I got all my z-scores are here, and I got all my z-scores here. What I need to do is multiply those together, right? So this is multiplication right here. And then, so I'm going to multiply those together. Then I'm going to sum them up and do all the other work, right? I'm going to divide by n minus 1, blah, blah, blah. Okay, so let's just multiply them out first. Okay, zx times z. So you can see I named this area. Right here, area. I'm trying to get back at that idea. I have a good graph down here that we can use to talk about. Okay, here it is. So this is an example of some data that's been turned into z-scores. This is the roller coaster data that we did. So remember we talked about any point that is up here with a z-score, like positive z-score, is going to have a positive area and is going to contribute positive amounts to your value of r. And then anything that's in the first and the third quadrant, right, down in here. Whoa, that's not what I wanted to do. Don't jump around. Okay. Okay. And then any point that was over in this quadrant, the second quadrant, right, or the fourth quadrant, anything over here, would end up giving us, whoops, I keep hitting the space bar instead of the command, will give us negative areas. So these will contribute to a negative R value and a negative slope. These two give you your positive slope if you have more of those, and vice versa. So I need all these areas, and then I'm going to add them up, right? Okay, so I have all those areas now, zx times zy. That's what I called my columns. So I just multiply those two out. And these are all those areas. All these positive numbers would be something in the first or the third quadrant. And these ones down here with some negatives in them would either be in the second or the fourth quadrant. You can see I have a lot more positive than I do negative. So it seems like there's a positive correlation, a positive association. Okay, so once you get your areas, the formula tells us to add them up. We need to add all those areas up. Sorry, jumping around here. Right, so we need to add all those areas up. So I'm going to call that, sorry, right here is where I'm going next. So you can see I took the sum of the area list. I went H1 to H13 because we had 13 students in the class. But it'll work just as well if you just type in the word area in here. See how it recognizes it, and then I hit enter. And that's fine, right? You can just say sum up the area list, and that will work. All right, then the last thing I have to do is just divide by n minus 1. Now in this class we had 13 students, so I divided by 12, n minus 1, and I get 0.866. One thing I want to mention right here, we had 13 kids in the class. So if this was perfect regression, like perfect regression, the areas of all those rectangles would actually add up to be exactly 12. And it's really weird why it's not 13 or something else. There's a lot of math behind it, but it's not 12. Or yeah, so this one's a little less than 12. Obviously, we had some negative numbers kind of pulling it around a little bit. So it's not perfect correlation, but there was a lot of positives. So we ended up with 0.866. Still very strong. Anything between zero point 0.8 and 1 is very strong. Anything between 0.8 and 0.4 we call moderate, and 0.4 and below, then we just say that is weak. All right, let's check our answer. All right, catch up first, get your value R. This is your R value. So to check my answer, I'm going to go over here and do a linear regression. Right, and just use my, you can see at the bottom here, I got height and R. Oh, that doesn't make very well. Let me get out of there. Just do a linear regression over here somewhere. And you'll see that the R value came up to 0.86611, perfectly the same as what we came up with. So hopefully going through this exercise, it gives you a little more depth of understanding of, how would you get R? What's the calculator doing to get R? It's just z-scores, and it's just z-scores, adding or multiplying those z-scores together to get an area. summing up all those areas, and then dividing by n minus 1 to kind of make it like an average. It's like an average area, right? When you divide by n minus 1. All right, that's it. Check your work, check your answers, and play around with it. Just again, this isn't like we're not going to make you do this whole thing on a test or anything, but it just is good for depth of understanding. So now, hopefully, when we ask you a question about R, then it'll be easier to answer because you have an understanding that it comes from z-scores, it works like slope, it comes from areas, all those things. Okie dokie, that's it right there. Next up on your list, if you look at the unit plan, here we go, February 21st, is to do this AP 2015 number 5 problem, and those should be handed out by your substitute. And then I want you to click on this link when you're done and check your answers. Now, I want the substitute to time you guys. I want him to give you 12 minutes to try to finish this up. It's not a hard problem, even though it's a number 5. So you should be able to finish in like 12 minutes. And then check your answer at the AP website. Okay, if you have extra time, we need you to start working on Chapter 7. Read Chapter 7, look at the class notes, study Chapter 7. Okay, we do have a couple of classes down the road. You see we have retests coming. So that is on the radar in the future. So keep that in mind. Maybe time to start reviewing. I'll probably hand out your folders next class so you can see them. Thank you.